This example is based on an actual coding situation that I was asked to review. So according to the business rule, there is only one segment B if it exists. The business requirement for this program was to read the root and the segment on the right side of the database in order to update a child segment on the left side. So the code needs to read the root or the root R and a C segment in order to update segment B. Now, the contractor said that his prior IMS shop required that all segments be read in hierarchical order from left to right. Then you get unique to get the segment to be updated based on the business requirement. And this was an interesting concept for me. That shop standard was to do use get unique or get net to read the root, followed by reading the required segments in the database order and using get net within parent, followed by get unique calls to do the update. And I'm assuming that this was to handle single positioning issues in that shop. During his code review, one of his teammates said he did not need to code so many calls, but they were not able to explain why, which is why I got called. The contractor had never heard of multiple positioning, which was in play for this project because the database was a FastPath DEDB or data entry database. And remember, position equal M is forced on for FastPath databases. His code worked, but his manager wanted him to understand how and why he think differently. This was option number one. Get unique for the root, get net within parent for C equal to, get net within parent for B, replace B. So we went from 6 steps to 5 steps. And this worked for position equal M, but not for position equal S. The reason it does not work for single position is the second call, get net in parent C equal to, put the position on C2, which is after segment B. Thus, when step 3, get net within parent B, that call would get a GE for a single position in PSB. But these calls work when multiple positioning is turned on. First thing that was explained was that the left to right reading in database order was not required as he was taught in his prior shop. Unique calls can be used to read the various hierarchical legs in any order and tend to reduce the total number of calls. This slide shows how to use the get unique call. Call number 1. Get unique to get the segment where R segment equals 1 and C segment equals 2. Position is on C2 and parentage is on C2. Call number 2. A get unique to read segment B under R1, setting the parentage on the root. This get unique destroys the parentage that's on C2 and places it on R1. The current position is on B1. Update the data for segment B. Call number 3 is to replace segment B. Get unique calls are expensive, and the shop where we were working had a guideline to use them sparingly. In other words, when reading lots of children segment, use get net or get unique for the root, and then use get net within parent calls to process the children. By using the get unique call, the total number of calls went from 6 to 3. This solution worked for both single and multiple positioning. If the PCB supports multiple positioning, IMS is tracking a non-current position on C2 and a current position on B1. This slide shows how the calls might have been done following our shop's guideline and if single positioning was in play. Get unique for the root, a get net within parent for the segment C, get net within parent for segment B using the first command code. Because of the first command code on this call, I think this call worked for both single and multiple positioning PCB. I do not have access to a ZOS machine running IMS, so I'm not able to test if the use of first command code allows IMS to back up for a single position PCB, but I think that is what happened. This solution uses 4 IMS calls, and 2 of them are the faster get next within parent call. Calls 1 and 2 can be combined into a path call to save another step. This is a very interesting and unusual option for single position PCB. Rearrange the order of the segment in the PSB. This was rarely done in our shop because most PCBs defaulted to multiple positioning. In the PSB, code the RC hierarchy leg before the RB hierarchy leg. Now segment C comes before segment B in the PSB. On the database, C is after the B segment, but the PSB can do a virtual reordering. This removes the requirement to use the first command code for the get next within parent for segment B. Again, call 1 and 2 can be combined into a path call. This is what the programmer knew. This gets the number of IMS calls down to 3. Get unique path call, reading segment R and C at the same time, setting the parent is on the root. The parent is must be set on the root so that the second call can be a GNP. The second call is a get next within parent for segment B. Update the data in segment B. The third and final call is to replace segment B. I want to show an extreme example of why position equal M is powerful and how it can save CPU and I/O. This code shows an unlikely situation, but it demonstrates the power of multiple positioning, and this is slide 1 of 2. Get unique for the root. Do the priming get next within parent for segment A. Do the priming GNP for segment B. You can visualize this by pointing at A and B. So you can point at A with your left hand and B with your right hand. Drop into the loop. At this point, the get next within parent for segment A will fail with a GE if the PCB only allowed for single positioning. But position equal M means that IMS moves position from A1 to A2. GNP for B, IMS moves from B1 to B2. Loop number 2, IMS moves from A2 to B3 and from B2 to B3. Loop number 3, IMS moves from A3 to A4 and from B3 to B4. And loop number 4, GE's trying to do a get next within parent for A and a GE to do the GNP for B. Exit the loop. Now we need to look at the next slide. This shows how to process A and B in parallel using single positioning. First thing to notice is there are 2 extra paragraphs are required. The 2 greater than paragraphs were added. Also, the first command code has to be used. Remember, there's only one position, so instead of being able to use 2 hands to point, one hand has to go behind your back. You can only point with one hand. Thus, each time your hand moves from A to B or B to A, you lose position on the other side. Get unique for the root. Priming GNP call to get A1. The priming get next within parent call to get B2. Position on A1 is lost. Enter the loop. Get next first A segment with a key greater than the current key in the I/O area for A. This call means, starting with the first A segment, find the one with a key greater than the key in the I/O area. So IMS finds A2. Same thing for B. Starting with the first B segment, find the one with a key greater than the key in the I/O area. So IMS finds B2. Repeat these greater than calls until a GE is returned. Because IMS has to start with the first segment each time, it is scanning the segment behind the scene. To return a segment with a key of 2, IMS has to scan A1 to get to A2. IMS has to stand B1 to get to B2. To return a segment with a key of 4, IMS stands segment 1, 2, 3 to return A4, and it has to do the same thing for segment B. To get the GE status code, IMS stands A1, A2, A3, A4 to return no data, and the status code is GE. Same thing for segment B. IMS stands the 4 existing segment, return the GE status code and no data. Exit the loop. As you can see, multiple positioning is able to avoid segment standing that is not possible with single positioning. Repeating that. As you can see, multiple positioning is able to avoid segment standing that is not possible with single positioning.